Hello everybody, Root Beer here with question number 21 on the grade 11 Fermat paper from 2005. We're up to question 21, the first one in part C. So let's have a look. 4 different numbers, A, B, C, and D, are chosen from the list -1, -2, -3, -4, -5. The largest possible value for the expression a to the b plus c to the d is, and then we have some fractions. Okay. So, things that are catching my eye, the denominator of the fraction, so this would, so this 4 down here would be something like, well, it can't involve a 2 to the 2, so maybe it's a 4 to the 1, that sort of thing. This isn't the easiest question to work with, because you sort of have to choose your 4 numbers and then choose how are they going to fit into this arrangement. So let's take a look at something like x to the y, because we want to make things as big as possible, right? So we want x to the y, and we know x and y are negative. Okay, so if you have something like 3 to the -2, the negative number means that you do 1 over 3 to the, assuming you had a positive number. So x to the y, actually, I'm going to change these guys to positive. No, we'll keep it as negative. I thought changing them to positive would make it a little clearer what's going on, but no. So we get 1 over x to the -y, which would then be a positive value. So it could be sort of like 1 over -2 cubed, or 1 over -1 to the 4, that sort of thing. Now, if we want to sort of maximize a to the b plus c to the d, it makes sense that we would have positive numbers here. We want a positive value for a to the b, we want a positive value for c to the d, add them up, get something positive. We don't want to be having negative numbers, because then that's sort of a to the b minus c to the d. If we have to go with that, that'll be fine, but we should focus on positives. And if we're focusing on positives, notice that -2 to the 1 is -2. -2 squared is 4. -2 cubed, -8. So this thing here is going to be positive only when -y is even. So that sort of limits the things that we can put for b and d. We want them to be even numbers so that a to the b and c to the d are positive. So, well, we only have -1, -2, -3, -4, and -5 to choose from. So b and d must be -2 and -4. That's the only way to get even numbers. So the question is now, what do we pair them with? It doesn't matter. I'm going to say a to the -2 and c to the -4. But it doesn't particularly matter. If you wanted -4 first, that's fine. We don't know what a and c are yet. So we get 1 over a squared plus 1 over c to the 4. So a squared, c to the 4, these are relatively big numbers. We want the biggest thing possible. How do we make fractions big? We make the numerator as big as possible, we make the denominator as small as possible. Well, we're sort of stuck with the numerators of 1. They're both going to have numerator of 1. But what we can do now is choose a and c, knowing that we've got 2 and 4, choose a and c to make denominators as small as possible. Okay, so we have options for a and c. So I don't know how I want to. I know the information I want. I'm just trying to think of how to express it. So if a is -1, we get -1 squared is 1. -1 to the 4 would be 1 as well. Again, positive values are good things. -3 and -5, suddenly then we're looking at a is 9, a squared is 9, a squared is 25. And we also get things like 81 and 625. If we want to make the denominators small, what are the smallest possible things we could have? We could have c be -1, and we could have a be -3. And that'll minimize these guys. Make it a little clear that we're dealing with c to the 4 as well. So I'm going to let a be -3 and c be -1. Because anything else for c gets way too out of control. So now, what do we have? We have -3 to the -2 plus -1 to the -4. And that's 1 over 9 plus 1 over 1. This is going to be 10 over 9. Is 10 over 9 one of the possibilities? Okay, it is. If it hadn't been one of the possibilities, I know that it's at least a value that I can get, and so I would then eliminate anything less than that, because we want the largest possible value. So, this is what I've gotten just by intuiting through the problem. You know, I said, let's try and focus on a to the b and c to the d being positive. Let's minimize these denominators. But maybe there's just some weird combination out there of a, b, c, and d that gets me something bigger. Is that possible? Are there any other options that they give me that are bigger than this d value, this 10 over 9? So both b and c are less than 1. E here is just 1/25 plus 1. This is 1/9 plus 1. So D is bigger than E, but A is 1/4 plus 1, and that's definitely better than 1/9 plus 1. So I have to ask myself, can I get 5 over 4? Is that possible? Well, how would I get 5 over 4? I would need something like 1 plus 1/4. Right? No matter what B and D and A and C are, so we would need to get negative numbers. All right. So I'll flip the page here. So 10/9 is looking good, but can we get? We get 5 over 4. And if you're very, very confident in what we wrote on the other side, you bubble in 10 over 9 and you move on. But it's still possible that it might be A. Is there some way we can rule that out? No matter what B and D we choose, A to the B plus C to the D is still 1 over A to the negative B plus 1 over C to the negative D. And these guys here are integers. So we're still, so both of these things are less than or equal to 1. Okay. So, if I'm going to get 5/4 out of something that's less than or equal to 1, and then this guy here is less than or equal to 1, is there any way I can do that? So we can't have, for example, C to the negative D be odd, because then we're doing something less than 1 subtract a value. That would make it even more less than 1. Otherwise, A to the B plus C to the D would be less than or equal to 1 minus negative C to the D. Which would be less than or equal to 1 minus 1 over negative C to the negative D. And I would bring the minus sign out if D were... So we can't have not C to the D be odd. We can't have D be odd. because if d were odd, then a negative number to an odd power, c to this negative d, would be negative. 1 over it would be negative, and then we'd have some value less than or equal to 1 plus a negative value. It'd be less than or equal to 1. And that's less than 5 over 4. So these both b and d have to be even. And if that's the case, how can we get 5 over 4? Well, again, we've got we've sort of got to go back to this chart, and there's no way, if 2 and 4 are already taken, the best that we can do is the 1 and the 9. There's no way to get 4. So you would sort of need 1, and then you'd need 1 over 4 to get 5/4. There are other ways to get 5/4, but this is sort of the way that they would be hinting at. But then this would be something like 1 over negative 1 to the 2 plus 1 over negative 4 to the 1. It just doesn't quite work out. You can't ever get the 4 that way. But the second that you say, well, could we get something else? Well, no, these guys are no bigger than 1. And if you want something that's bigger than 1, you've got to have b and d be even. The second you have b and d be even, we're back looking at this chart, and the best you can do is 1 and 9. C is 1, C is negative 1, A is negative 3. So 10 over 9 is really the best that we can do. And we've double checked it. So really all we did was just go around a little bit of a circle here. But 5 over 4 can't be done. So we get D. And that does it for question 21. If you got the 10 over 9 and you were confident in that, you've probably moved on to question 22 by now. But it's important to say, could it get A? No, it can't. All right, so that's we're going to look at question 22 in the next video. Thank you guys for watching. I'll see you next time.